In this session, we're going to watch another video of on-site interview. In this on-site interview example, I will interview a candidate who got his bachelor's and master's degree in computer science, and he has several software engineer internship experience. And in this interview, I will ask 3 questions. The first question is about his previous internship project. Basically, I want to see how he could introduce his past project and how he could tell about his exact contribution to the project. The second question is, for the 2 input strings, he is asked to find out the inserted character. You wonder, this question is the same as one of the questions in the previous on-site interview example. Yes, it is true. The reason why I ask this question again is to see how 2 candidates with different education level approach the same problem. The third question is actually quite challenging. On 2-dimensional space, like XY plane, let's say we have a lot of points and we have a camera on the center of the coordinate system, and the camera has some viewing angle called field of view. He is asked to find out the angle where the camera can see most points. Let's watch the video. Nice to meet you.
Nice to meet you.
I think I got your resume, and your resume looks very interesting.
Thank you.
Can you elaborate more about your intern project about AL, that drone position estimation that you done last year?
Sure, we have. It was actually really a quick project. We worked on it for 2 weeks or 3 weeks. It was pretty simple, and I should tell that I don't write any NDA or
it's totally fine. Yeah.
Tell about this project. So it was an art drone. And it flies over like windmill and do some kind of stuff which it must do. But there was a problem that there is only one mono camera in this art drone from the bottom and only one from front.
So 2 cameras are looking downward.
Yes. So it was not a stereo vision, and it was. Really hard to estimate the position of this drone. It was a big error. So my project was respect to find the position of this art drone using stereo vision. We have 2 cameras, and we put some kind of stuff like orange ping pong ball, and this art drone is pretty close. So. And we try to use a simple trigonometry in order to find this position in 3D. And we tracked it over all frames.
What is your contribution in this project?
It's almost done by me. Only one guy look at results and tell.
So putting the ping pong ball is your idea, you implement it in the system?
Actually we can put any ball or small stuff.
Okay. Cool. Yeah, that's very good.
Thank you.
Yep. I have one quick question about basically algorithm question. What I want to ask is if we are thinking about a function, and then the function will have 2 input strings. So C, B, A, Z, H, for example, and then another string input is C, B, X, A, H, Z. So what the output is character X, because X is the inserted character. So there is no guarantee that the character will be inserted to first string or second string. So
it's only one position of this character.
Only one character. And then what you want to return is the inserted character.
All right. So there is a really. I should write a function.
Anything, right? No. If you think you can finish quickly, you can write a function, or you can just think of some algorithm first.
All right. Just basic approach from the beginning, straightforward approach. It's to maintain a hash map of these characters. So just simple array of 26 elements, because if we have only small Latin characters.
Oh,
but it's
right.
better to maintain hash map, I guess,
Okay.
for this reason,
Okay.
and put all characters from the first string into this hash map, and after that we can just loop over a second string and just see is the hash map contain this character. If not, we just can return position and value of this character. So,
Okay.
it works in big O and memory, and it works a little bit S1 size and S2 size. So it works in S1 plus S2 time. It's a time complexity, and memory complexity gonna be S1. But it's amortized complexity, because hash map works amortized it in OR.
So, so what you just mentioned, and what is the? Could you define the map, the hash map? Like, what is the key? What is the value?
For example, STD, nor
yes.
the red.
Map,
For example, we can use for this set, because we not care about indexes.
Yes, that's the point that I want to ask. Are you going to use a set or a map?
It's better to use set, of course.
Wait. How about this?
Mm-hmm.
Input character is this, and then out. No, S1 is this, S2 is CCCCC.
Mm-hmm.
Does your algorithm work with this example?
In this case, it will not work, because my approach works only if it's this character not repeated on another string. I thought it's a unique character. So in this case, we need to create another approach.
Okay. Yes. Again, the question is try to find the insert to the character, not the unique insert to the character.
Oh,
you
sure.
Understand, right?
In this case, we can just make a straightforward, simply approach. Also, for example, we can maintain two unordered maps, like std unordered map for char, and int is going to be count of number of elements in such letter, and let it be I don't know, count one. We can create more.
So can you tell me just algorithm?
Sure, we can contain in first hash map we will contain letter, for example A, and the number of elements in this string, for example 5A, and also we maintain another hash map, and so we just will iterate over second hash map in random order and see if, for example, in second hash map we have 6 elements, but in first we have only 5 elements, so we should return that these characters. And also we can quickly check that all parameters in this task correct, because, for example, what if it will be 2 unique characters or kind of this.
All right. So what you're gonna do is you're gonna generate basically a histogram of these characters for an input string. So you will have one histogram and a second histogram, and then you're gonna compare the histogram one by one, and then if there is any insert to the character, that's it.
Some kind of this.
Yeah, like in this case it's a 5, this is 6, and then if, like in this case, how are you gonna compare?
How for this case?
Okay. The number should also be the same.
Sure.
Okay. Can you tell me the complexity of this algorithm?
Of course.
Yeah, the memory and the time.
All right. Let's see. It's in time complexity. Let's see. It will be big O of size of first string, because we put all elements, and the size of second string, and we just iterate over alphabet of this, so it's gonna be +1. So this is time complexity, and it's amortized complexity because we use unordered map, because insertion and search in unordered maps works in order O of 1 and amortized. So memory complexity will be the same because we put all elements like in this approach. No. So memory complexity will be minima from size of string 1, for example, and alphabet size.
Yes.
And plus the same for second string.
Yes.
In this case.
Yeah.
But probably we can. Definitely, we can solve this problem using only one hash map, for example.
How?
It's not a big issue. For example, we know that in second, like this, we just put all elements on this map from first string, and we just iterate loop over second string and decrease number of elements for this value, and after that we finally loop over this hash table and see if all elements should be equal to 0 and only one should be -1, and so we can return the value of this element.
Okay, sounds good.
So its time complexity will be is it needed or
no. Yeah, the time complexity is still the S1 and S2, and then memory complexity. Because basically you have to read both of them.
Yeah, sure.
And then the memory complexity will be
less because we use only one.
Yeah, for extremely large input characters, it will be like alphabet size times some constant, like the integer size of integer. So eventually will be the same as the alphabet size. And what, like in this case, you will have one hash map is required. Okay, that's good. Yeah, both of them is a linear time.
I know another problem when we have only two twin elements and only one the same and or one unique, and we need just to XOR all elements.
But the sorting requires no.
I thought that it will be this task, but I said, oh no, it's like well, no.
All right. You're right. You're very good. The making a histogram type of structure and then put everything into there is a very easy way. Like if it is not sorted like that.
Thank you. In future, I'll tell it in histographic.
Well,
I just thought in terms of.
In a strict speaking, it's not a histogram because an histogram is defined upon the probability, not actually counter. I think counter is the correct definition.
It's okay.
Yeah, and just one another way. There is another way. Now this is the correct way. Let's say that, but you have a very limited amount of memory.
Let me see. You think maybe, or if you would like to discuss.
Of course. Yeah, that's fine.
All right.
Let's say you have a very limited amount of memory.
All right. In this case, we have a lot of time memory. So in this case, we just can we just put pointer, for example, here it will be 3 element, and we iterate over second string and see, for example, let me think. I guess there is a solution which works like multiply.
Yeah.
S2 and maybe something else, but I need to think.
I understand. Then
it's we go for second one, and we just move this one.
Whoa!
But
how about this?
How about this? No, so we need to find here when we move. We need to move this one, but
is there any way algorithm like make this plus and then constant memory algorithm?
Probably yes, but all right. To find only unique element, right?
Yes. Yeah.
The task is the same. We don't need care about checking input, right?
Yeah. Okay.
So
I think it's totally fine. No, I think that I don't want to ask like something really popping things up type of thing. No, this is very good solution. This is totally fine. There is algorithm to achieve this, like the linear time complexity and then constant memory complexity. Is no. Stop. Let's stop it. No, let's stop it. Which is XOR.
You want to prove which is XOR?
Yeah. So
Sure. Yeah, definitely. We should XOR all strings. Wow.
Is B.
So Steven, sorry.
No.
Yeah, I thought about XOR solution, but
no, for those who knows what it is, they can easily find out what these.
Oh my god.
B A is equal to B.
Mm-hmm.
You know already.
Yeah. So we just XOR both string, and the results will be this unique character. Wow.
Yeah.
Oh.
Yeah. So like in this case, if you have two threads or two cores, and you have input strings really long.
Yeah, it's the best solution. I thought about XOR, but I don't think. Wow, we don't have a twin elements. It's obvious that
both of them, and then you will have two outputs, and then you will have XOR two outputs, and then you will return that.
So funny. All right.
No, and then in many candidates do not know what XOR is, how to use that. They may learn that operator in the data structure class or algorithms class. They may forget.
The most disappointment that I thought about XOR solution, and I also mentioned about it, but no,
yeah,
it's obvious.
It's horrifying. No, I'm not asking something really their knowledge, and I'm not asking your knowledge if you remember this or not, because you studied this concept in your class and you don't remember what you're totally fine.
All right.
Yeah, next question.
Sure.
This is a coding question. I want you to write a code. Let's say that you have a camera.
Wow, I have a camera.
Yes.
Mm-hmm.
And this is field of view.
Mm-hmm.
You know how to, because you work on drone camera related thing. I want to give you some two-dimensional camera.
It's just two-dimensional.
Yes,
right.
two-dimensional.
Oh, nice.
You have points.
Mm-hmm.
No, I'm gonna draw like that.
Can they be inside of it, or it's just a point?
Just point.
All right, and angle and direct.
So the input signature is the question is that you have a camera. What you want to know is the angle where you see most points. So the basically the return value is, let's say they use a double find most point angle, and input is of course pointers on points, point and field of view. Camera center. Vector.
It's point.
Point. Yeah, point.
We have several centers.
No, this is the camera center.
Why we need to use the vector?
No. Oh, you're right. It's just this. Okay, and then double. It doesn't need to be double. It just maybe the float should be fine. But field of view.
Oh, actually.
Does it make sense?
Yeah.
So
I mean,
field of view defines this angle, and then you want to define. Let's say this is a coordinate system, Cartesian coordinate system. All right. Okay. And you want to find out the angle. This is let's say beta. You want to find out the angle. Like in this example, probably this is the answer, and you want to have a camera like that because there are so many points here. Right.
Is it possible, for example, to sort these points, or is it too large that I'm not able to sort them?
It's up to you. Yeah, of course, no, in many cases, and we assume that points are many, maybe million.
Oh,
Yeah.
if million, it's will works fine because sort million points is just it's okay. So
Yes.
all right.
Okay, let me stop here. We're gonna keep watching the remaining of the video in the next sessions.